Hi everybody, welcome back to another IBIPSA Education webinar on Occupant-Centric Simulation-Aided Building Design. If you haven't already read the book that this webinar series is based on, I'll pop a link in the chat shortly for you to check it out, and you can download the book for free. So today I am delighted to welcome Clarice Bleil de Souza, who's Chair of Design Decision Making at Cardiff University, and she's going to be talking about occupants in the building design decision making process. And so I'll just give you a little bit of background to the webinar and the format that we're going to be using today, and then I'll invite Clarice to get started. So this webinar is presented by the IBIPSA Education Committee, and we exist to identify education and training needs throughout the building simulation performance community. So do please get in touch if there's any training needs that you think that we could help serve. You can get in touch via the mailing list, you can use the IBIPSA website, or contact us on LinkedIn. We're always keen to develop and encourage new education material and methods. And a core part of our mission is that these training sessions are offered to non-members as well as to members. So in this session, Clarice will give her presentation, which should take around 35-40 minutes. If you have questions, then please do pop those into the Q&A box as we go along. And then at the end of Clarice's presentation, I'll put those questions and answers to her. And the recording for this session will be available on our YouTube channel, along with all of the other webinars in this series and all the previous series as well. So I'll give you the address for that shortly. But now, Clarice, I'd like to invite you to share your screen and we can get started.
Thank you very much. Thank you. I'll share my screen. Let me see. How do I do that here? Okay, here. You should all be able to see my screen now. Can you see it in slide mode? Okay, great, great.
Thank you very much.
Thank you. Thank you very much, Pamela, for this opportunity. Thank you, Jingfeng, very much for the opportunity and for the whole of IBEPSA, especially the IBEPSA Education branch, for inviting me for this webinar. I am Clarice Bleil de Souza from the Welsh School of Architecture in Cardiff University, and I'm here today to give you a taste of our book chapter on occupants in the building design decision-making process. This is chapter 3 of the book, Simulation-Aided Occupant-Centric Building Design Theory, Methods, and Detailed Case Studies, which was one of the outputs of the IA Annex 79 project. And this chapter was co-authored by myself together with Dr. Simon Tucker from Liverpool John Moore University, also in the UK, Zsófi Demi-Belafi from the University of Budapest in Hungary, András Schreit, the head of ABUD, and also from University of Pécs in Hungary, and Runa Helvig from Aarhus University in Denmark. So let's see if that's passing now. So let's talk a little bit about the chapter, which discusses the challenges of integrating considerations of a building's occupants and occupant behavior into the decision-making process of building designers, and also outlines a framework to achieve this. So where do we start? We started by the overarching principle that occupants' considerations must be formally integrated into the building information management systems to ensure that they are not lost or ignored throughout the design process. And nowadays we have in practice a complex scenario full of unknowns, permeated by liabilities, regulated by contractual documents, which are used to provide clarity on the information that each design team member needs to provide, and also receive to enable ongoing design discussions and procurement, meaning the timely exchange of information between team members and different disciplines is crucial. So what we cover in the chapter is basically we start by discussing how the recent changes in design practice that aim to facilitate performance and risk assessment in relation to legislation, regulations, and client portfolios can affect building occupants. We then discuss the role of information management in coordinating these changes and propose how information and decisions about occupants can flow throughout the design process in a coherent and coordinated way. We discuss the impact of design decisions on occupants within built spaces, followed by an overview of design considerations affecting and affected by occupants. And here we particularly focus on the different types of interactions that occupants have within and with buildings, as well as with the buildings surrounding them, the environment surrounding them. So we then finally propose the construction of what we called occupant-centric design patterns, or OCDP, which is kind of a framework to record and support information transfer regarding occupancy and occupant behavior throughout the design decision-making process. But it is in a way that fits and supports currently industry-used building information modeling and building performance simulation tools. So the occupants in a building affect how a building performs in many ways. And the building that is designed, built, and eventually occupied will influence the behavior of its occupants. But we know that performance of this building when in use will depend on how the building design responds to what the occupants need, the amount of control that the building designers have afforded these occupants to have, and how well the design team have anticipated how the occupants will want to use the building and its systems in the future. So this all depends on how design decisions are balanced to achieve overarching project targets. These targets are negotiated among project team members, propagated into the information flow in design processes, and then subsequently revised as the project develops. And there are several stakeholders involved in this process, which is primarily shaped by the interests of the client and the procurement process put in place to contract and commission a design and construction project. So now let's start by examining a little bit the role of the client in shaping information about occupants, starting by defining who is the client, the entity or individual organization commissioning and funding the project, and therefore the ultimate decision maker in any project. We know the client can be occupant or the owner letting or leasing the building to occupants, and that distinction is for us very important because it affects the way decisions are made. So if the client is the landlord rather than the occupant, he or she or the company is very likely to see the building as a financial asset, and therefore they are going to be aiming for maximizing rate of return on investment and setting operation targets which follow potentially shared conventions and agreed forms of standardized description, measurements, and provisions. So this is especially true if the building occupancy has a large turnover. Consultation with occupants are highly unlikely to happen in this case, and they might either be unknown because the occupants might either be unknown or out of scope of client's objectives for different reasons. But if the client is the occupants, then we are in a situation in which the client objectives are more in tune with the occupant's objectives, especially considering consultations happen at different times throughout the design process for project approval, ensuring design objectives and all the information that are aligned with client occupant objectives. So factoring this in, the first thing we proposed was to categorize different types of information on occupants used throughout the design process, considering their type, their source, and their role in practice, especially with regards to their relevant to projects and their respective impact in contractual arrangements and responsibilities. So we then created this table, which you can see in the slides, which starts by cataloging what is mandatory information about occupants, such as, for example, the building regulations. They are always present and considered an important milestone in project approval. It's also difficult to find projects that do not use normative information about occupants, for example, evaluative standards. Because, for instance, energy performance and comfort standards are generally used to set up project targets. And also ergonomics information forms part of the vast majority of project layout proposals. So you should be able to read more about normative informations in chapter 2 of the book, which is dedicated especially to that. And we also found out other types of information, such as, for example, business-oriented information, which may sometimes overwrite parts of normative information, such as, for instance, client operational targets, especially if the client is not the occupants. We can also see overwritings by lessons learned, for instance, metering, monitoring, post-occupancy evaluation, etc., or by information coming from consultation with occupants, if, for instance, the client is the occupant. But because in this case, the client occupant is more likely to share risks and liabilities with the design team, they are then potentially being keen to use information, you know, from what they want to do with the building and also lessons from previous buildings and so on. But if the client is not the occupant, then we are more likely to be sticking to the 3 first rows of the table. So chapter 4 of the book will discuss extensively about consultations with occupants, and chapter 6 and 7 will then explore lessons learned. But why did we do this classification? Because performance-based legislation and regulations are starting to promote more emphatically the use of lessons learned in new projects towards developing fit-for-purpose designs, because occupants have a clear role in relation to how they influence efficiencies in operation. And this is being reflected in the design process through changes in, for instance, plans of work, which now refer to information management standards related to building design and construction. Also asset management standards, and these documents in which are now being passed to clients. So core principles related to more fit for purpose design is incorporated in procurements. Now, design and operation are now seen as a continuum by these documents. They're all coordinated together. And in this case, design targets are verified in the operation phase, transferring joint responsibility for the client and the design team in terms of their needs and aspirations for the occupants. However, it is still up to the client to set roles and responsibilities, so the operational phase activities and performance targets align. So measuring the targets now is like an activity that is constantly revised and adjusted as the project develops. And this demands for proper coordination of information throughout the project life, which then forms an important record for project quality control for later auditing for liability purposes. Now let's get a glimpse of how information about occupants propagate throughout the different design stages. And for this, we will use a series of documents produced by accreditation bodies in the UK and the USA, for example, as you see in this table. In this table, we try to put together where and how the different types of information provided in the previous table that I showed before informs the UK and USA design delivery stages. We only look at the design stages. We didn't look at construction and commissioning. And since they vary country by country, the design stages, as a function of basically when planning application and building regulation approval is needed, we then generically define them as pre-design and design. So what we now have are plans of work that are fluid with regards to the granularity of information to be provided at each design stage, because this information is tightly related to the procurement routes and contracts. And these are the legal documents which contain the responsibilities and project deliverables and specify milestones for information approval and auditing. So now, so how does the industry cope with this fluidity of targets? Some new project management strategies are put in place to cater for them. For example, integrated integrated design process, integrated project delivery roadmaps, and so on. They are considered quite useful to inform on management strategies and steps to better integrate project goals related especially to social, ecological, economical, and sustainability performance, and are supposed to facilitate the implementation of shared risks and liabilities in contracts so that you can, for instance, have lessons learned and consultations with occupants more broadly used. But We know the construction industry is risk averse, so they are rarely used in practice. And like all the other project-related guidelines, such as information management frameworks, procurement routes, project management approaches, or guidelines to practitioners, they do not really provide methods to transfer information about occupants in integration with performance management throughout the building projects. So decisions about occupants are normally scattered within project documentation and not linked to tools used in design, especially BIM and building performance simulation. So designers are again left with no means to record information about occupants and their behavior in a single information environment. And this makes it difficult to insert occupant information into BIM models and also coherently transfer them to BPS, or building performance simulation models, so that the decisions can be integrated within building performance simulation. This is why we believe that design decisions related to occupants and occupancy in general need to be seen in the context of information management, especially now that documents issued by professional accreditation bodies have been all revised and amended to fully embrace the idea of BIM and the new ISO standards. So practice now is pushed to comprehensively develop digital models, which in theory facilitate design for manufacturing assembly and can be constantly refined until they become asset management models. And these models are federated, so they mirror the different disciplines involved in a building project, enabling information exchange and design decisions to be better controlled and coordinated by the design team. So information about occupants needs to be connected to the objects of this federated model. And what exactly are these objects? They are packages of information, for example, of construction assemblages, of room usage, etc., that are manipulated by different members of a design team in BIM environment. These objects can, in theory, contain any kind of information and be part of libraries, for example, containing descriptions of repeated simulations, occupancy profiles, design requirements, design aims, decisions, etc. Like other BIM objects, which are stored with all their attributes in different types of BIM libraries. So what we propose is to start by looking at how occupants can be part of the four most common types of BIM objects, namely the construction entities, which are basically the buildings that we are designing, the built spaces, which are spaces clearly defined by the built environment to host specific activities or equipment, for example, space for living, working, etc. Construction elements, which are the different components of a construction entity, for example, a wall construction system, a furniture system, etc. Construction properties, which are the attributes of a construction element, a built space or construction entity, for example, thermal performance, shape, size, etc. So we then examine the different types of design aims, requirements, considerations, and decisions related to these four elements, discussing first the impact of decision on occupants within built spaces, and then we look at how occupants affect and are affected by these decisions when interacting within and with the construction entity, as well as with the environment, natural or built, of the wider site, to then openly explore these connections of occupants with these objects. So initially, we looked at how design decisions impact on occupants within built spaces, and we can say that designers impose constraints, either consciously or unconsciously, on occupants. They can vary from lack of flexibility and adaptability, for example, in relation to the way occupants can use spaces, down to the control of environmental systems. And these constraints are set based on different information sources, building regulations, standards, targets imposed by clients, and even lessons learned from previous projects, which might constrain the occupant to use the building the way clients intended to be used. So we can see examples of this, for instance, in energy efficient standards. But persuasive strategies are also starting to become part of design agendas, especially with the wider implementation of automation and smart controls, imposing conditions without allowing for occupants to override. And these strategies are many times supported by client expectations for occupant behavior and energy efficient guidelines, and give a false impression to designers that occupants can be persuaded or directed to specific behavior. And an iconic example of this is the known rebound effect. Affordances are, for instance, what building offers to its occupants with minimal cognitive effort. And they include the environment the occupants are in and the way of life or actions possible within this environment. This means that intended effects designs can have on building usage and also include unintended ways occupants find to use the building, which depend a lot on how designers interpret the way occupants behave. So when designers want to design buildings which is significantly shaped by the way people live, they have to put themselves in the position of the occupant to predict expectations and adaptive needs that might occur within the spaces. That is, they need to design with adaptive opportunities in mind. And for this, lessons learned and consultation with occupants can provide valuable information. But unfortunately, far more is needed to increase their uptake in practice because we know from previous analysis that a lot of this is down to client decisions and therefore translate into contract risks and liabilities. So now let's have a look at decisions affecting or affected by occupants which constrain or persuade occupants, but also define potential affordances, adaptive opportunities for occupants to interact within and with the building and its spaces. So let's assume for this that climate, site, building type, and the overall conditioning strategy for the building are understood, and define and brainstorm a series of decisions related to how occupants will interact within and with the building, as well as with the environment of the wider site. For example, when deciding about building orientation, designers might have to, for instance, provide a place for children to play in the sun, and that influence occupants' interactions within the building. When deciding about evacuation routes, designers are likely to, for instance, provide a safe route to the outside, properly defining wayfinding for occupants to interact with the building in a safer way. When deciding about building form and volume, designers might have to, for instance, configure outdoor courtyards using the building to shape how occupants will interact with the environment of the wider site. Now, these interactions are complex and context-based, but the design decisions about building and its spaces are surprisingly typical because the design team has always a finite number of built spaces to manipulate towards achieving these goals. And when we look, for example, at decisions about transparent element operation, designers might have to, for instance, enable the sitting area to be part of the street, therefore influencing occupant interaction within the building. In decisions about the control of shading devices, designers might have to consider ease of shading use, enabling occupants then to interact with the building in a productive way. And in decisions about opaque elements, construction and properties, designers might have to protect cavities against pests, for example, proofing the building from certain interactions with the environment for safety of the occupants. And again, here we see that the interactions are complex and context-based, but the design decision, specifically the decision about the construction element and the construction property, are surprisingly typical. Because again, the design team has a finite number of objects to manipulate towards achieving project goals. So our intention here is not to cover all possibilities for interaction, but to highlight the richness of a design process and how these decisions are thoroughly interwoven with occupant interactions. And that information about occupants and occupancy can actually come from different sources for these decisions to be made. So in any case, what we try to show is that occupancy-related information can potentially be linked to common objects designers manipulate, with these objects carrying information back and forth to the design team. And when we put these two tables together, as you can see in the slide, we can see that design decisions gradually become more specific and detailed. So if a design team wants to integrate considerations about occupants to design practice, the design team needs to be prepared to record this information, the information about occupants, throughout the process in a structured way so that this information can be easily recalled as the design progresses. And this is especially important when decisions are done using building performance simulation to test potential design options. For example, if we want to add shading, ventilation, insulation, thermal mass, etc. Because this job might be done outside the design team, meaning not only the results and design modifications, but the changes in occupancy assumptions need to be properly documented when the information is handed back to the designer. And messing up with this would have a significant effect when designing, for instance, for adaptive opportunities, which are particularly useful in improving performance in passive design. So thus, recording decisions related to occupants in object-oriented environments seems to make sense from this perspective. And we know far more research is needed to establish how these links between BIM objects and information about occupants can happen, especially considering that BIM and BPS ontologies do not match. But in any case, if decisions affecting or affected by occupants are recorded and manipulated in a kind of object-based environment, information about occupants and their behavior can then be documented through links between these objects. And pathways with these links can therefore be traceable and provide some evidence-based information to clients and design teams and as the project starts developing, while at the same time being stored for reuse and future projects. So what we try to do in the chapter, we try to finish the chapter with the idea that we can record that, and we try to show a template for producing occupant-centric design information, which then captures decisions and objects in their design contexts. And here I reinforce the importance of the contexts. So the template intends to show designers how a current design problem and its solution might affect occupants or is itself affected by them. So this type of template could be attached to or associated with the relevant construction entity or built space, but could also be linked to construction elements and construction properties. And these what we call problem solution pairs, which you see the pink and the green, are seen as a powerful way to transfer and share knowledge and quality control design solutions, because they enable expert knowledge normally deployed in a tacit form to be formalized so that it can be stored and assessed from novice designers to experts. We call this template or this framework as Occupant-Centric Design Patterns, or OCDP, and they are inspired by the work of Alexander and the colleagues, further adapted by Simon Tucker and myself in previous publications. So these occupant-centric design patterns, they describe common situations where design decisions will affect occupants and propose design solutions that will take occupants' needs into account. In this way of recording information has been highly influential in computer science, known as object-oriented programming, where programs are then are a number of self-contained objects that are linked to other objects. Each object contains like blocks of code to reuse, saving the encoding time and maintaining quality, while at the same time enabling various members of teams to work on different parts of the code. So what we propose is that each design pattern describes one problem solution pair, which is with these instructions on how to use it, examples of its use, descriptions of the context in which it's used, and links to other related patterns. For any particular building project, a number of appropriate patterns can then be selected, and they can be adapted into object-based models as the pair solution problem is structured in a consistent and reproducible way, and they can then be linked through the BIM system to a building model. So the structure of the pattern was adapted by Simon and myself to encapsulate expert knowledge from building performance. And here it is used to integrate relevant occupant-related information, for example, models to be used, analytical process to be put in place, and to make them also available in a user-friendly way to building designers. So if we zoom into the solution part of the pattern, we can see an outline of its solution plus its simulation elements, which contain, for example, aims of the pattern from a simulation perspective, simulation model settings, processes and analysis involved in the simulation, simulation outputs, interaction with the model and outputs that should be afforded in visualizations related to the pattern, etc. If we zoom into the problem part of the pattern, we can see that the context in which the pattern is inserted in, and also the context in which a decision needs to be made. We can also see a synthesis of the type of problem being dealt with, and examples, which in this case refer to information from chapter 11 of the book, which discusses an eco-housing case study in Hungary, in which a consultation with occupants was done to build occupancy schedules and test the impact of these schedules in the building use. This particular example focuses on energy performance aspects of the building occupancy, as there are clearly they are clearly related to building simulation and also have a combination of technical details. But we can also make occupant-centric design patterns more broadly, and we can include non-simulation design aspects, for example, such as the ones developed in tables previously shown to prove what clients want in relation to post-occupants evaluation things and so on. So, and the end here part of the pattern shows the quality assurance procedures for implementing the pattern and ensuring that it runs properly, and also other patterns which can then be connected to this pattern. So different information types, which can vary from recording mandatory information about occupants up to information coming from consultation with occupants, for example, and can be considered either as an alternative to this one or complementary to it. We can also record at the end of a pattern comments for further development of this and follow-on patterns, as their development should involve a process of consensus among experts with constant revision updates and also integration at various design stages. So occupant-centric design patterns focusing on performance would address then the recurring issues of achieving comfortable conditions, provision of healthy environments, testing of effects on uncertainty, on equipment and system sizing, economical operations of the building and systems. They can be whatever topic you want. And they can form part of a library of patterns, better connecting design decisions with different types of performance to then be simulated and assessed. So the idea here is basically that we try to argue in the chapter that information about occupants need to be properly documented throughout the design process. So it is linked not just with the building performance simulation, but also with the BIM to fit within information exchange happening between team members with especially different disciplinary backgrounds, so that it supports collaborative initiatives from a technical perspective. And what we attempted to do was to develop a way to record and trace design decisions related to occupants in a single environment that is compatible with BIM federated models and building performance simulation tools, so that multiple assessment points can then be scheduled throughout the design process, and design decision-making can be evidence-based and better integrated with performance in use. Now, the advantages of supporting design decisions using a kind of object-based information system is that the discussion does not become tied to project stages, but it can be seen as kind of a big Lego of generic objects detached of country-specific systems and contracts that you just plug here and there as you see fit. With then different levels of details can be set to a single object and then recalled as design progresses, making it possible to develop and record context-specific entities, but in a centralized environment that can then open the door for future work to implement this structure within common BIM tools to facilitate agility and distributivity in decision-making. So this would enable us then to record sequences of combinations and also store them for future retrieval, then developing blueprints for how occupant information flow cascades down design projects. It should or would hopefully also enable us to identify how similar problems and issues concerning occupants reappear across projects. And from this, we can then create corporate object libraries, which link with building performance simulation tools and occupant behavior modeling tools to inform performance assessment. And then in this library, decisions can be recorded in context and need agreement from all involved stakeholders to avoid mismatches between design goals and also misalignments between design intentions and occupants' expectations throughout the stages of the design process. So the process can then become transparent and traceable, which is very much the idea behind supporting liability and also aiding in risk assessment. It also then enables on potential solutions or best practice to be made easily accessible to design teams. And we can then, as you can see the pyramid, ideally move from data processing to shared understanding by combining this pattern recognition with context knowledge developed through concerted agreement among practitioners. So I thank you very much for hearing and invite you to read chapter 3 of the book. I hope you have fun. The book is open access, as Pamela stated earlier, and I open the floor for questions. Thank you.
Thank you, Clarice. That was fascinating. And such a rich topic as well. So we have currently, we've got some questions in the Q&A. If you've got any other questions that you'd like to put to Clarice, then please do take this opportunity to put them in. So the first question that we have is about residential buildings. And the questioner asks, when we have the government or the developer as the client who are providing units to the occupants, they usually don't know who the occupants are when it's still in the design stage. And is it possible to develop an occupancy model to obtain occupants' input in that stage, particularly when it relates to bespoke layouts of the units?
Yes, I invite the person that formulated this question to read our chapter 11 of the book, which is sort of about that, not specifically on bespoke residential buildings, but on shared, on eco-friendly residential buildings for low-income communities with shared facilities. But the idea is the same. So what they've done is they basically collected a lot of different schedules of occupancy and use from the different standards. They put them all together. And also they did a workshop with the prospective end users of the building or the occupants. And then they also try to understand patterns of use and occupancy and put all the schedules together. They then had a load of different types of schedules to simulate different occupancy types. And for that, they could then develop different scenarios and then test for robustness of the project against these different scenarios. Yes. So yes, we do have a chapter of the book that explores the issue of robustness. And we also have a chapter of the book, chapter 4, which Clinton is going to talk, I think it's the next webinar, in which he will then explain how to collect information from the occupants more specifically to be able to develop these schedules in more detail. But our example in chapter 3 uses chapter 11, and it's kind of a template to show different ways, well, to input different schedules from standards as well as occupants themselves into simulation, and then what to check and what to quality assure, etc.
Thank you. That was very comprehensive and really great to be able to look at the detail of that example in chapter 11. I have a question next, which is about whether there's the potential to update and annotate the patterns over time and do a kind of longitudinal study to see how things evolve over time, because while there are obviously gaps initially, which might be due to a lack of understanding, over time the needs of the occupant, even if they were understood perfectly at the outset, will obviously evolve, and how you can take account of that.
Yes, that's a very good question. Actually, the idea of patterns is to be a dynamic instrument and not a static one. So you set up a template in place so that you start recording information. And of course, you can modify and you can have even different versions of it. As you have more information, as you enrich, as you have more experience about a certain problem solution pair, or as you have even different variations of a problem solution pair that can come. But the principle is to be able to create a template to record, because if you don't record, you don't keep trace of it and you cannot work on it. So the idea is that it doesn't stay still. It is like a tool to start this recording process that can then be enriched gradually, and potentially we can reach a situation in which certain patterns are so true, let's say, that they can be then public domain, or then, kind of more, I wouldn't want to call it static, but at least, kind of more common knowledge that is then useful to disseminate, especially to novice designers and to novice simulation experts. So yes, by all means, they are not supposed to be a static a thing. They're supposed to be a dynamic thing, but really a template to start this recording and to start building these libraries.
That sounds incredibly useful. And can I just ask from perhaps more from a UK perspective, we obviously have, in some sense, there are patterns of occupancy that are used for compliance modelling. So that's of the national calculations methodology, and obviously there are sort of equivalent examples in other contexts as well. Have you done any work or thought about how those map to actual patterns that you see people using in practice? How realistic these very standardized patterns are?
We did not check, we did not verify the standard occupancy schedules and recommendations of this sort, because they are normally coming in the form of schedules plus, ratios of energy use or something like that. I think, as far as I remember, Chapter 11 does use UK NCM, because I'm sure they use ASHRAE. Now I can, maybe if I go back slides a bit, I should be able to see that, because we did document that. We did say, yes, so ASHRAE, UK NCM, and the French THBC. So you can find potentially a comparison, as you asked for, in Chapter 11, because they did use NCM and they also use ASHRAE standards. So you should be able to see the different schedules and how they compare with each other. Now, our purpose, we were concerned about recording information. So we didn't look at the details of the different schedules and how they are provided, because that was a bit beyond the scope in the sense of validating them. But in this case, you can see that we put together them as part of the solution, because you can collate a lot of schedules and then analyze them together to see, to check for robustness. So this was the idea of the pattern, was to be able to explore the different energy use in this co-housing, but with the idea of robustness.
That sounds like really interesting and important work, given how much emphasis is placed on those. So I shall certainly be checking out Chapter 11 as well.
But just a note for your question. I think one important point to make is that NCM, because it is referenced as a national standard and is part of accreditation and compliance, they will be preferred to be used by designers because it is the safety route, right? Is the liability coverage and all of that. So that is something we quite clearly try to emphasize on the chapter, that if you want to use alternatives to this thing, to standards or to things like that that are seen as like widely acceptable, accredited, etc., then it is important that this is recorded, potentially compared with the standard and so on, because these people will want to protect themselves primarily against liabilities. So you have to be having that in mind, that any proposals are many times not uptaken by the practitioners because they are very concerned with the liabilities and they need to see how they can cover for that. Once that is dealt with, then you have a more open opportunity for dialogue.
Absolutely. And particularly when resources are tight, if you have to use the NCM schedules for compliance modelling anyway, why it's difficult to see why someone would necessarily go and explore further, although we do know that obviously in practice there are very significant variations. And thank you, Clarice. That's been absolutely fascinating and really educational for me, and I'm sure for everybody else. I'd just like to close then by telling you a little bit about what is coming up next. So I will just share my screen and we can see a little bit of a reminder about the next sessions in this series. So coming up, as Clarice mentioned, on the 20th of March, we have methods to obtain the occupant perspective. And then that's followed by a series of webinars taking us right through to the end of June, which works through the book chapter by chapter. So it's a great idea to look at the book alongside the webinars and use the webinars as a way of really deepening your understanding. Alongside this particular webinar series, we are also running another series which is on urban building energy modelling. We have had in the past quite a theoretical series on urban building energy modelling, and now we're having a more tools focused series which is in response to requests from some of the members and participants. So the next one of those is coming up on the 5th of March, and that's Christoph Reinhardt, who'll be talking about ubem.io. And then in May, we have Jeroen Kempf, who's going to be telling us about City Sim. So do sign up for those. You can use those QR codes there as well. Now, the recording for this webinar will be on our YouTube channel shortly. I'll post it on LinkedIn when that gets uploaded. And you can also see there the webinars from all the previous series that we've had, as well as the rest of this particular series, which is ongoing just now. So you can subscribe to the channel to be kept up to date when new content is added, and you can find in the comments on each of the recordings, you can find the sign up links for the remaining webinars in the series. And so the final piece of food for thought is that I would encourage you to consider joining IBIPSA as a supporting member. The supporting members enable the broader work of IBIPSA, including these webinars, and in return receive a subscription to the Journal of Building Performance Simulation, either a print subscription or an online subscription, whichever you prefer, and they have the right to use the IBIPSA supporting member logo. Now, the prices for this have been unchanged for about 5 years now, so they're remarkably good value. Depending which one you go for, you can either have the print subscription or the online subscription, and you can find out more at ibipsa.org/membership. But thank you very much for joining us. I do look forward to seeing you again at one of the next webinars, either on the 5th of March with Christoph Reinhardt talking about ubem.io, or on the 20th when we have Clint Andrews talking about methods for obtaining the occupant perspective. But before we go, I'd just like to say again a very big thank you to Clarice for that fascinating insight. Thank you very much, Clarice.
Thank you. Thank you, IBIPSA Education, for the opportunity again.
Thank you. Thanks, everyone. Bye.
Bye.